Here's another function that might not look like it can be solved with natural log. They want us to differentiate something that's already a natural log, but I'm going to tell you a secret. It still works. Before I differentiate this, I'm going to add natural log to all of this. And it might look funny, but I think it's going to work. So I'm going to take ln of y equals natural log of x to the x. And why? For the same reason. Anytime I see an x in the exponent, I'm going to want to add natural log to both sides because I can bring the x out to here and rewrite this as x ln of all of this. Even if it's a natural log of a natural log, I don't care. I care about that exponent coming out so we can use a product rule or something like that. Okay, so let's differentiate now. Let's take dy dx for everything. What's the derivative of natural log? That's 1 over the input times chain rule, function on the inside is y prime. I often call it dy dx. We'll call it y prime going forward for brevity and keep things clear. Now we can use a chain rule. Here's a function of x and here's a function of x, right? So the chain rule says it's u prime v plus v prime u. That's simple enough, so we're going to do that. Well, what's u? That's this x, right? So u prime is 1, and v is this ridiculous looking natural log of a natural log, plus v prime. Now we're getting into some harder stuff here, right? Because the outside function would be 1 over, and then the input would be ln of x, times the derivative of the inside, which again is going to be 1 over x. Yeah, derivative of this natural log. I think that's accurate. And then we have the x function here. V prime u goes at the end there. So how do I clean this up? Well, let's multiply the y over. So we get a y prime equals y times natural log of x plus, and these canceled out, so that's nice. We'll call it 1 over ln of x over here. Am I allowed to do that? Let me think on this for a second. I think that's allowed, right? It feels like it's allowed. Is there any reason that can't be allowed? Maybe we can also do a natural log over a natural log there. Is that too much? What was our y value? Our y value was natural log of x to the x. So I think our y prime is equal to natural log of x to the x times, I really want to put natural log of x on top and bottom here, but I don't think it's going to make it any cleaner. Natural log of x plus 1 over natural log of x. Oh, that looks a little janky there on the bottom. Oh my gosh. Okay, I believe this is the right answer. So you're getting a few natural logs in here. But it's correct. And the lesson here, again, is when you see any kind of function with an x in the exponent, you're going to want a natural log wrap that whole thing up so you can bring the exponent down and then do a basic product rule. And whatever comes out, that's what comes out.